Pandas, Python data tool. Pandas is a popular Python library for working with data. It helps you load, analyze, clean, and transform data easily. Pandas is very useful for data science, machine learning, and business analytics. Real-world uses include loading CSV files, statistical analysis, and working with Excel data. In Pandas, you use special objects called series and DataFrames. These make it simple to handle big collections of data just like you do in Excel. Running the cell now. If you are on Windows, install Pandas using a pip install pandas. Then run these lines to begin using Pandas. This turns off warning messages. This line imports Pandas and lets you use it as PD. Running the cell now. This code sets up your environment by importing the Pandas library, which is essential for handling data in Python. Although there's no visible output, this step is key because it enables you to use powerful Pandas functions to load, analyze, and manipulate data in later parts of the lesson. Ignoring warnings here helps keep your workspace clean while you focus on learning. Core Pandas objects. Two main objects in Pandas are series and DataFrame. A series is like a single column of data. A DataFrame is like a whole spreadsheet or table with rows and columns. Running the cell now. Let us create a series. This makes a series with 4 numbers. This shows the series on screen. Running the cell now. This output shows a Pandas series, which is essentially a single column of data indexed by default with integers starting at 0. Notice the left column represents the index, while the right column holds the values, illustrating how a series combines both data and labels. This reinforces the lesson's point that a series is a core Pandas object representing one-dimensional data. Let us create a data frame. This creates a data frame with name and age columns. This shows the data frame on screen. Running the cell now. This output shows a data frame with 2 rows and 2 columns, name and age. Notice how each row has an index number, 0 and 1, and the data is organized much like a table or spreadsheet. This illustrates how data frames hold multiple columns of related data, which is the key idea behind this lesson. Beginner example, reading data. Pandas can load data from files like CSV. Here is how to read from a simple CSV file into a data frame. Running the cell now. This saves a small CSV file to use for the next example. This opens a file called sample.csv for writing. This writes example data into the file. Running the cell now. In this step, we've created a simple CSV file named sample.csv containing 2 columns, name and age, with 2 rows of data. Although there is no visible output yet, this file serves as the source we'll read into a data frame next, illustrating how Pandas can load data from external CSV files. Let us load the CSV file into a data frame. This reads sample.csv into a data frame. This prints the loaded data frame. Running the cell now. This output shows the contents of the CSV file loaded into a data frame, with columns, name and age, and 2 rows of data. Notice how Pandas automatically assigns row indices starting at 0, making it easy to work with tabular data in Python. This confirms that pd_read_csv successfully reads the file into a structured format ready for analysis. Beginner example, selecting data. You can select columns and rows from your data frame. This makes it simple to work with only the data you need. Running the cell now. Let us select only the name column. This takes just the name column from the data frame. This prints the names. Running the cell now. Here, the output shows the name column extracted from the data frame, containing 2 entries, Alice and Bob. Notice how selecting a single column returns a series with the index preserved, making it easier to focus on just the data you need when working with larger datasets. Let us select just the first row. This gets the first row of the data frame using iLock. This prints out the first row's data. Running the cell now. Here, the output shows the first row of the data frame, displaying Alice's information across all columns. This demonstrates how iLock 0 selects a specific row by position, allowing you to focus on individual records when analyzing data. Notice how the output preserves the column labels, which helps you understand the values in context. Beginner example, modifying data. You can add new columns to your data frame easily. Let us add a new column called Country. Running the cell now. Let us add a new column to the data frame. This adds a column called Country with USA and UK. This prints the new data frame with country included. Running the cell now. Here, we added a new column called Country to the existing data frame, which originally had only a name and age columns. Notice how the new Country column aligns correctly with each row, showing that you can easily expand your data frame by assigning a list with matching length. This simple step demonstrates how to modify and enrich your data structure in Pandas. Intermediate example, filtering data. You can filter rows to show only data that matches your needs. Here, we select people older than 25. Running the cell now. Let us filter the data frame for people older than 25. This gets only the rows where age is more than 25. This prints the filtered data frame. Running the cell now. The output shows only the rows where the age column is greater than 25, filtering out younger individuals to focus on adults. Notice that Bob, age 28, remains because he meets the condition, demonstrating how filtering lets us narrow down data based on specific criteria. This is key for analyzing subsets relevant to our needs. Let us count how many rows for each country. This counts the values in the country column. This shows the count of each country. Running the cell now. This output shows the counts of people by country after we filtered the data to include only those older than 25. Notice there is one person each from the USA and the UK, illustrating how filtering affects which rows remain and thus which values appear in our summary counts. This confirms the filter worked as intended by narrowing the dataset before counting. Intermediate example, sorting data. Sorting rows helps you find the highest or lowest values. Let us sort by age in descending order. Running the cell now. Let us sort the data frame by age from highest to lowest. This sorts the data frame with age in descending order. This prints the sorted data frame. Running the cell now. Here, the data is sorted by the age column in descending order, so the oldest person, Bob, appears first. Notice how sorting rearranges entire rows based on the age values, helping you quickly identify the highest ages in the dataset. This demonstrates how sorting can highlight key insights by ordering data efficiently. Intermediate example, basic statistics. Pandas can quickly calculate statistics for columns. We will find the average age. Running the cell now. Let us find the average of the age column. This calculates the mean value of age. This prints the average age. Running the cell now. Here, the code calculates the average age from the age column using pandas.mean function. The output, 26.5, summarizes the dataset by providing a single representative value, demonstrating how simple it is to extract key statistics with pandas. This helps us understand the central tendency of the ages in the data. Advanced example, joining data frames. You can merge or join data frames like you join tables. Here, we add email info for each person. Running the cell now. Let us make a data frame with emails for each person. This creates it with name and email columns. This merges the data using name as the matching key. This prints the new data frame with emails included. Running the cell now. This output shows the result of merging two data frames on the name column, adding email addresses to the original data. Notice how each person's email is correctly matched and appended as a new column, illustrating how joins combine related information from separate tables. This reinforces the lesson's intent to enhance datasets by joining complementary data. Advanced example, handling missing values. Real-world data often contains missing values. Pandas makes it simple to find and fill them. Running the cell now. Let us make a data frame with missing values. This uses none to represent missing data. This prints the original data frame with missing values. This fills all missing values with 0. This prints the data frame after filling missing values. Running the cell now. This output shows a data frame with missing values, nans, in columns L and B, which is common in real-world data. The second print demonstrates how fill 0 replaces these nans with zeros, ensuring no gaps remain. This highlights how Pandas simplifies handling missing data by filling them with specified values to maintain dataset integrity. Error handling in Pandas. Sometimes, your data loads wrong or you pick a wrong column. Pandas gives an error message to help you fix it. Let us see what happens if a column does not exist. Running the cell now. Let us try to select a non-existent column. This starts a try block to catch errors. Trying to select the height column which does not exist. This would print the value if it was there. If there is a key error, we catch it here. This prints out the error message. Running the cell now. This output shows a key error because the code tried to access a non-existent column height in the data frame. This error message helps you identify exactly which column name is missing, emphasizing how Pandas alerts you so you can correct it during error handling. Debugging tips. Use print often to see what your variables contain. Use df.info for a snapshot of your data frame. Use try and except to handle errors safely. Running the cell now. Let us look at the data frame structure. This shows columns, types, and missing values. Running the cell now. This output shows a quick summary of the data frame df_CSV, confirming it has 2 rows and 3 columns, name, age, and country. Notably, all columns contain non-null values, indicating no missing data, and their data types are displayed, which helps verify if the data has been read correctly. Using df.info is a key debugging step to quickly understand the structure and completeness of your dataset before proceeding. Best practices. Use clear, simple column names. Check your data types with df.dtypes. Avoid changing your data too much in place. Save copies of your work using .copy. Comment your code so others can understand it. Running the cell now. Let us print the type for each column. This shows the data type of each column in the data frame. Running the cell now. Here, the output shows the data types of each column in the data frame, confirming that name and country are text, object, and age is numeric, int 64. This check is key to ensure the data is correctly typed before further processing, aligning with best practices to understand your data structure without altering it prematurely. Mini project, analyze student scores. Let us use Pandas to analyze a small set of math test scores. We will load the data, calculate statistics, and find the top student. Running the cell now. Let us create the data frame for student scores. This makes a new data frame. Student names go in the student column. Scores go in the score column. This prints the scores table. Running the cell now. Here, we created a data frame containing student names and their corresponding math test scores. Notice the clear pairing of each student with their score, setting us up to easily compute statistics or identify the top performer in the next steps. This structure is essential for efficiently analyzing and manipulating our data. Let us find the average score. This calculates the mean. This prints the average score. Running the cell now. This output shows the average math test score across all students, calculated using the mean function on the score column. Noticing this average of 88.0 helps us understand the overall performance level in the dataset and sets a baseline for further analysis, such as identifying top performers. Let us find which student got the highest score. This finds the row with the top score. This prints top student. This prints out the details of the top student. Running the cell now. This output shows the top student with the highest math test score from our dataset, highlighting Dan, who scored 95. By using IDSmax, the code efficiently identifies the row with the maximum score, directly supporting our goal to find the top performer in the class. Notice how the output includes both the student's name and their score for clear interpretation. Want more Pandas videos? Subscribe for more step-by-step data tutorials. Running the cell now.